Welcome to the final exam, question number 13. And it asks, which of the three span beams shown below are statically determinate when subject to a uniform load? And I don't think we've ever actually gone over what statically determinate is, but it is something that is pretty darn important in structural engineering. Determine it. Maybe we have, and I won't get into the book definition, but what statically determinate means is it's easy to figure out what the reactions are. I hope that makes sense. Statically, sorry, my little boy's here. Welcome to the final exam, question number 13, and it asks us, which of the three span beams shown below are statically determinate when subject to a uniform load? So each of these has a uniform load on it that looks like this. I'll just throw these on there pretty quick. But and we don't need to draw them on every single one, but as a uniform load on each one of these, you get the point. And typically you want to look at statically determinate. I think we've been over this. I don't remember if we have or not. Anyways, the equation you want to use is R equals 3n, I think it is, yeah. 3n. R equals 3n. And usually you could look at this as reactions or forces, I guess. I would call R equal forces or reactions. And then n is your number of members. And I think that this problem is pretty darn hard, in my opinion, because it's not this straightforward equation. I would say, oh, okay, you know what? Well, sorry about that. Let's go back up. Oh, there we are. If it were this just straightforward, you could use this equation. That'd be fine, but it's not. And that's what makes it more difficult. Like, for instance, if you could say, oh, well, you know what? I have 1, 2, 3, so that should be 3n, so that's 9, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You're like, oh, wait, you know, that's too many. But I'm not going to use it this way, and I think that's why I think this is difficult, because it's not a straightforward question. Well, like I said, I believe I said earlier, is it statically determinate means you can figure out what this is. You can figure out the loads, the reactions, and that's what I would say go ahead and do, is try to figure out the reactions. And I can kind of go in a back way to figure it out. But what you can do is just cut it, and can you figure out what the reactions are? For instance, we'll cut it right there. Let's just give these some arbitrary numbers. We'll say this is 10 foot, 10 foot, 10 foot, and we'll say this is 100 PLF. Okay, let's cut it at 5 foot. So this is what, 5 foot? And you now have, and I always, actually I'm going to make this go down. I'm going to make this go down, and I'm going to make this M. And we know, since there are no horizontal forces, we don't have any, I would call it a P load going like this. So we know, actually I'll go ahead and put that on there. So that's P. P equals 0. And then this is a V. So this is V, and that's P. I could probably put these in different colors to make it a little bit more obvious. V's up there, I'll put it in green. P is right there, and we'll do M in purple. There we go. So, I guess the question is, can we figure this out? And we also have this 100 PLF at 5 foot. So you're going to have this equivalent load. 100 PLF at 5 foot equals 500 PL, or 500 pounds equivalent load at 2.5 foot. I hope this all makes sense. I'm going pretty quick about what my assumptions are. And the whole question is, let's call this A, B, C, D. So this is at A, this is the reaction at A. Can you figure out this stuff? So for instance, if you want to sub the moments, could you do it? Actually, let's first try to sum the forces in the y direction equals 0. And you have RA is positive, minus 500 pounds, and then minus V. So you have two unknowns right now, which you can't solve for. Now let's do the sum of the moments about the cut, I guess. Let's call it the cut. At cut equals 0, and we say, let's say this is positive, and we'd have RA times 5 foot, and then we'd have what? Negative 500 pounds times 2.5 foot, and then you would also have plus M. So in this circumstance, you also have two unknowns. So you can't solve either of these equations, even if you substituted and you made this equal to RA, for instance. Let's try that. Say, hey, maybe we can substitute. Make RA equals what? It'd be V plus 500. If it would be V plus 500, then we substitute RA right there. V plus 500 pounds times 5 foot. And then that's what? 500 times 2.5 minus 5. I'm just going to put like this. 2.5 foot, and then plus M. You still have two unknowns. You still have V, and you still have M. So that really doesn't help you. In the end, you can try this yourself. Try to solve for the reactions and see if you can figure it out. I, on the other hand, can't. And that's why I would say that this is statically A, or which one is this? Number 1. This is number 1. I would say it is statically indeterminate. And I don't think that's 100% the easiest thing to figure out right away. I'll show you at the end how maybe you can figure it out. If it's statically, well, maybe how these are statically determinate. But anyways, you go down to here, and can you figure these out? And the whole issue here between this and there is when you cut it right here, it had what? Two unknowns. It had an M and a V, and then you have the reaction. So that's three unknowns for one beam. Now right here, when you cut it, given the fact that P is still going to be 0 because we have all vertical loads, when you cut this right here, you can cut this right here. And for instance, you're going to have something that looks like this, let's say. This is 100 PLF, right? Yeah. And this doesn't give us a distance. Let's say it's 8 foot. Now, obviously, this doesn't matter. 8 foot is 800 pounds. We do the math. We actually would have this, but P equals 0. This would equal 0. Hold on a second. So you'd have what, an 800 pound equivalent load. You could do your sum of the forces or sum of the moments about this point. This would be twice as much, or you could just know, hey, this is coming in the middle. This is going to be 400 pounds and 400 pounds. Now, when you cut it right here, how many unknowns do you have? You know this. You know V. Well, it wouldn't be really V. Yeah, you could call it V. You know the force at this point, the reaction you could call it, and then this is unknown, and this is unknown. So you have two unknowns, and one, this is now 400 pounds. You can just sum the forces about this direction, and you'll get this reaction, and then you can sum the forces in the y direction, and you get this reaction, and you do the same thing with this side. It would be exact same, and it works. And this is the same thing. You could do this. You would take a cut right here, and say you would get the equivalent load, and you would have, if you look at the cut section, you would have your reaction right there. You would have a V reaction. You could make this be going down. Sometimes people like to make it go down. And you don't have a moment. These are pins. I don't know if you knew that. These are pins. Let me change colors real quick. These are pins. That's a pin. That's a pin. This is a pin. This is a pin. And on all pins, a pin does not resist a moment. So, since you no longer, up here, remember we had this moment. But down here, we do not have that moment. And therefore, since we don't have a moment here or here or here, you can solve for it. So therefore, you only have two unknowns. You cannot solve when you have three unknowns without, I won't say you cannot. It's not statically determinate if you have three unknowns. All right, I hope that makes sense. So, but I said I kind of try to explain a back way of getting about this. And the back way is saying, hey, since we have no horizontal loads, instead of having three possible equations of equilibrium, you have two possible equations of equilibrium. Yeah, close enough. So what you can say is per every, instead of saying you know how earlier we said R equals 3n, we now have R equals 2n, but this comes with a caveat where these pins, right here is a pin. This, instead of having two reactions, it only has one. Now it has one reaction, Rxn. Because it's assumed, since we have, it tells us this, what I'll call a P load going down the axle, is 0. P equals 0. Therefore, now what we can do, and I'll go to pink, it's a little bit more noticeable. I will use this. I will say every member times 2 is equal the number of reactions given that the pins are only 1. So I'll just number them. 1, 2, 3, 4. All right, so this is going to be 4 now for this one, and then this will be, as I said, is going to be 2. Now, since I have one number, I should probably do this. Equals 2. No, because I might have confused somebody other way. All right, now we come down here and we said every pin is a 1. So 1, 2 pin, 3 reactions, 4 reactions. And we have, this is now equal to 1, so that's 5 and 6. But now we go to number of, we have 1, 2, I won't circle these. We have 3 times 2, so he said we had 6 equals 2 times 3 equals 6. That means it's statically determinate. And so it's the same issue for down here. And I know that's very, very confusing because the determinacy is slightly confusing if you haven't dealt with it very often. But the easiest thing to say is, can I figure out the reactions? If you can't figure out the reactions, it's going to be statically indeterminate. If you can, then it's going to be statically determinate. I will see you on question 14.